Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving construct binary tree from preorder and postorder traversal. Now if you don't know what a preorder tree traversal or what a postorder tree traversal is, I will highly recommend watching these two videos first. It's only about 2 to 3 minutes, so that is how I learned what a preorder and postorder traversal is. So I will highly recommend watching these two videos. Anyways, let's get back to the problem. So the problem states that given two integer arrays, preorder and postorder, where the preorder is the preorder traversal of a binary tree of distinct values, and postorder is the postorder traversal of the same tree, and we want to reconstruct them and return the binary tree. And if there exist multiple answers, you can return any of them. So if you look at this example, we have the array of the preorder traversal and the array of the postorder traversal. And based on these two inputs, we want to be able to reconstruct them into a binary tree. So if you have learned preorder traversal and postorder traversal, manually, you should be able to put them into a binary tree, but it may not be as simple to code out the algorithm. But now that we have seen some examples, let's get to how we can solve this problem. So one way that we can solve this problem is that we can use two pointers, and it will involve some recursion, but how it will work is we will start with the preorder. We will add the root value that we are on to that node, and then we will increment the preorder after adding the root value. And then we will check if the current root value that we are on is equal to the postorder pointer. If it is not, then we will look to the left or the right depending on where we are at, but we will first recursively call to the left first for this algorithm. And if they are equal, then we just skip both the recursive call and just increment the postorder, and then we will return the root. In other words, we increment the preorder index before the recursive calls, and we increment the postorder index after the recursive calls. So I think it will make more sense when I go through this example. So let's go over this example right now. So first we look at preorder. We will add 1 as the root, and then we will increment it, but we're still at 1. So we compare 1 to the postorder. They are not equal. So then we would look to the left. We'll recursively call to the left, and we look at the left since we're on 2. So then we will add 2 again, increment it. And since 2 and 4 is not equal, then we will recursively call to the left again. And since now we are at 4, so we will add 4. And after adding 4 as the root, we need to increment it, and we compare 4 to 4. They are equal, so we will skip the left and right recursive calls, and then we would increment the postorder index. And now we need to recursively call back to the previous 2 node, since 2 has not gone through the right recursive call yet. So now we're on the right side, and we set the preorder, we're at 5, so we set the right node to 5 and increment it. And since the value we are on is equal again, so we increment the postorder, since that means we can skip the recursive calls. And now 2 has finished the right and left recursive calls, so we need to increment the postorder index again. So now we're on the right side of the right recursive call of the first 1 node. So 3 is where we are at, so we add 3, and we need to increment 3. Now we come to 6. 6 is on the left recursive call, so we add 6, and we increment it again. But we compare 6 and 6, they are equal, so we increment the postorder. And now we are on the right recursive call of 3, since 6 has already returned, and look both to the left and right. So now 7 is where we are at, so we add 7 to the right recursive call, and we increment it over, but the root that we are on is equal to this, so we increment it again. And then now 3 has completed its recursive call, so 3 is equal to 3, so we increment again, and now right has completed its right recursive call, so we compare the value after the recursive calls, 1 and 1, so we increment again. So time complex would be O of n, where n is the number of elements in the preorder and postorder array, because we have to iterate through these arrays. And the space complexity will also be O of n because of the recursive stack that we may have to go through. So now let's get to the coding part. So first we'll set the pre-index to 0, and we'll also set the post-index to 0. And then now we're going to call our helper function self.construct preorder and postorder, and after calling it, we're going to make the helper function right below. So define self, and then preorder and postorder. Okay, so we will first set the root to a tree node But we'll call it root, and then tree node, and it will be the preorder. That's what we're looking at. So self.preindex. And remember, we increment the preindex before the recursive calls, so preindex plus 1. And now we need to check if the root value is equal to what's on the post index. If it is not, then we recursively call to the left. Post index. And if it's not, we call to the left. So root.left is equal to self.construct preorder and postorder. And now we will do the same thing, but on the right node, the right recursive call. So if root.val, same condition. And then root.right. So the same thing, same call. Preorder, postorder. And remember, after the recursive calls, we just increment the post index and then return the root. Okay, let's see if it works. Okay, perfect. Thank you all for watching. Hope this was helpful. If you have any other questions or comments, feel free to leave it down in the comment section, and I hope to see you all again soon.